In this section, we will learn how to plot points using polar coordinates. When asked to plot a point on a graph, you probably think of plotting an ordered pair in the form of a rectangular coordinate, such as the point x, y. That's what we're familiar with. This is an example of plotting on a rectangular or a Cartesian coordinate system, and that's really what we're used to. However, from work done in previous videos, another way to measure the location of a point is by knowing its distance from the origin, which is called the radius, and its angle measure from the positive x-axis going counterclockwise. Because of this, rectangular coordinates, x, y, can be expressed in what is called polar coordinates in the form of r, theta. In this polar system, the polar grid is a series of concentric circles radiating from the pole or the origin of the coordinate plane. So polar coordinates are written as r, theta, and like I said, they are a series of concentric circles, the graph is, radiating from the pole, and the pole is the origin. So here's my origin. That is what we would call the pole. The polar grid is scaled as the unit circle with the positive x-axis as the polar axis. So the positive x-axis, or the horizontal axis, we might say. The first coordinate r is the radius or the length of the directed line segment from the pole. Now we're going to look at examples of all this to make sure that it's clear. But in this picture, we see we have an r, theta down in the fourth quadrant. Now we could estimate this point by first identifying theta, which is the angle from the polar axis to the ray that goes through that point. Now, to me, that point, or excuse me, that angle looks like it might be, let's see, from this polar axis. To me, it looks like the theta is going to be, maybe 7 pi over 4. Does that look like a theta of 7 pi over 4? I think it does, knowing that 2 pi would be all the way around, and 2 pi is 8 pi over 4. Second, we would then estimate the radius of the concentric circle that the point lies on. Now, I attempted to draw that circular, but I'm a little bit off. To me, it looks like this radius is approximately, let's see here. So if I look at those concentric circles, I have a radius of 1, I have a radius of 2, I have a radius of 3, and a radius of 4. So it looks to me like the r is somewhere in between a radius of 3 and 4. So I might let the r value be around 3.5. So I could estimate that this polar coordinate in the fourth quadrant is the polar coordinate 3.5 as a radius with a theta of 7 pi over 4. Now, thinking a little bit ahead, you might have been wondering, well, why did I pick 7 pi over 4? Could I have picked something else? And we know that there's other ways of getting to that fourth quadrant angle other than 7 pi over 4. I could add multiples of 2 pi. I could take away multiples of 2 pi. I could write this as a positive angle. I could write this as a negative angle. So one thing that we'll discover as we move forward is that while there's only one way of writing a rectangular coordinate, there are multiple ways of writing polar coordinates. And that can be really helpful in some applications. Let's look at an example where we're being asked to plot a point on a polar grid. A polar grid has been provided with some of the common angles labeled. Multiples of pi over 6, pi over 4, and pi over 3 can be seen on this polar grid. And then we have concentric circles. It looks like we have a radius of 1, 2, 3, and 4. So hopefully that'll be enough space for us. And on part A, we're being asked to plot the point 2, pi over 3 on this polar grid. So we might first want to just say to ourselves, okay, well, what does that 2 represent? The 2 represents our radius, and the pi over 3 represents our theta, right? That's r comma theta is a polar point. So we're going to look at this step by step. Step 1 is to locate the angle measure. So this is a little bit different than rectangular coordinates that are in the form x comma y, where normally we would start at the origin, 0 comma 0, and we would go an x direction and then a y direction. For polar points, we're going to start with the second value, which is the theta, or the angle measure. So pi over 3, I know, is located in the first quadrant, so I've located it. Step 2, from the terminal side of this angle measure, we're going to draw a directed line segment. So a directed line segment is that terminal side. So if I'm starting on the polar axis, pi over 3 is going to open up to that terminal side, and I'm just going to draw that in and call it a directed line segment. Step 3, I'm going to mark out r units from the pole on this line segment. So my r value is 1 and 2. And what I'm going to do is now put a point there, and that point represents 2 comma pi over 3. Now, what happens if r is negative? For example, in part B, it says to plot the point negative 3 comma 5 pi over 6. Well, if r is negative, then the directed line segment that we've drawn will actually be drawn in the opposite direction as the given angle. And that's where the ordered pair can be plotted. So let's take a look at this one. We're going to start out with the first step. So step 1, we know, is to locate the angle measure. So 5 pi over 6, where's 5 pi over 6? It is over here in the second quadrant. Step 2, from the terminal side of this angle measure, we're going to draw a directed line segment. So again, we started on our polar axis, and the terminal side of 5 pi over 6, we're calling that a directed line segment. Now, because we have a negative r value, we're going to extend that directed line segment the opposite direction directly across. And it's on that directed line segment that I'm going to mark out 1 and 2 and 3. And that is going to create the polar coordinate negative 3 comma 5 pi over 6. Now this can feel confusing because even though we have a theta of 5 pi over 6, you might notice that we're actually sitting at 11 pi over 6. But that is because of that negative radius. It takes you directly across. And again, another thing to point out here is that we can see that there are other ways of representing this polar point. So we called it negative 3 comma 5 pi over 6. I think we could also call this, let's see, what else could we call this? If the angle measure were 11 pi over 6, then we would be sitting at just a positive 3 as a radius. We wouldn't need to go over to the other side. We could call it, let's see, what else could we call it? We could call it an angle measure of negative pi over 6, and then still have a positive 3 as a radius. I suppose we could probably, if we want to keep the negative 3, we would just need another way of writing 5 pi over 6. So instead of going to, let's see, 5 pi over 6, we could add, right, a whole rotation to that. Take us into the same location. And 5 pi over 6 plus a whole rotation would be what? So 5 pi over 6 plus 2 pi, which is like 12 pi over 6. So another way to write this might be negative 3 comma 17 pi over 6. And you know, in order to answer this question, is there another way to represent a point on a polar grid? Yeah, I mean, I think we've just looked at 1, 2, 3, 4 different ways. How many ways are there? The answer is that First of all, yes, there are, and there are infinite ways. Infinite ways. And we're going to get more into the specifics of that in another video.